All right, we can just go ahead and get started here. Welcome, everybody. Can't believe it's January already, mid-January. Today we are joined by Dr. Etienne Sutton of the Great Lakes Cover Crop Project. She's going to be sharing some of the latest research updates, how farmers can get involved in this work, an exciting new app in the works looking at cover crop performance. So after Etienne presents, we'll have time for questions and discussion with the whole group. So Etienne, I will pass it over to you. Thanks so much for being here today.
Yeah, thank you for having me. Let me get my screen set up here real quick. Okay, are you seeing a slide?
Looks great.
Wonderful. Okay. Yeah, so thank you so much for having me today. As Emily mentioned, I'm Etienne Sutton. I am currently working with the University of Missouri as a researcher with the Center for Regenerative Agriculture. But prior to that, I was with the University of Michigan for a long time, did my grad school research there, and that's sort of where the Great Lakes Cover Crops Project originated. And now I have a number of other things happening, so I thought I'd give you an update on Great Lakes Cover Crops Project, as well as a couple of other things that I have going on at the moment. Yeah, there's been quite a bit of research activity over the past year. A lot of it is focused on community and citizen science research efforts, so that's sort of the focus of what I'll be sharing today. And just to quickly get us all on the same page, I first wanted to just touch on like what I mean by community and citizen science. It can take a lot of different forms, but really at its core, it's referring to public participation in the research process. It's a really effective way to do applied research for several reasons. First, it's a really great way to learn with and from practitioners like yourselves. We know that farmers are super innovative when it comes to sort of figuring out how to make different practices work. And so this approach allows us to identify those innovative practices and systems that seem to be working really well and share that information with other growers, or even use it as a jumping off point for future research trials. Second, when we partner with growers to gather data from real farms, it means that the results we're producing are actually practical, actionable, and can be more easily translated into management recommendations. And then finally, the research is much more likely to actually affect change when farmers feel like they can trust the data because it's coming directly from other farmers and their experiences. So, this is sort of my bread and butter. I do a lot of community and citizen science research, participatory research, etc. So, as I mentioned, I have a few different projects going on right now that I'll talk about today. The first of which is the Great Lakes Cover Crops Project. This project has been going on since 2021 now. It's reached over 200 farmers across the region, and it has actually now led to another spin-off effort to create what we're calling a cover crop performance app, which will be starting development of this month. And then the last one, the cover crop variety testing network, is relatively new, just about a year and a half old so far, but it's already generating some really promising data. So we'll start with the Great Lakes Cover Crops Project, which I talked with this group about last year, but just as a quick reminder, the entire premise behind the project is that so many of the benefits that we hope to get from cover crops really do depend directly on cover crop growth or biomass. There's quite a bit of research at this point showing that the more biomass there is, the better the weed control. There are fewer nutrient losses to our waterways. You get more biological nitrogen supply from the legumes that you plant, and just overall greater soil health benefits. So, to get the most out of our cover crops, in a lot of cases, we do want to focus on how do we generate more biomass. But we also know that there are a lot of different factors that influence cover crop biomass, ranging from things like soil conditions to the planting method you use to the amount of experience that someone might have with using cover crops in general. So we've been using a community and citizen science approach to crowdsource data from farms all across the Upper Midwest region to understand what seems to be working well and what doesn't across these different growing conditions. The key to getting lots of people to participate in an effort like this is really to keep it simple. So, all that we ask from growers is to first complete an online management survey in the winter, right about this time, that asks about characteristics of their field and farm, as well as cover crop specific questions like the species, seeding rate, planting method, nutrient management, etc. And that provides us with important context for sort of interpreting cover crop performance. And then to actually measure cover crop performance across all of these fields, we use a quick and easy farmer-led protocol that just involves collecting ground cover photos, weed pressure ratings, and then stand heights right before termination in the spring. And with that information, we're able to calculate cover crop biomass in pounds per acre for each of the fields participating in the project. So just to give you an idea of the types of farms and fields that we've had participate in the project so far, this is a roundup of all 3 seasons worth of data so far. You can see the geographic distribution by season on the left, showing that we've had really good participation from Michigan, where I've been based for the past decade, and have pretty good farmer networks here. And then we also have really good participation from Minnesota, particularly during this most recent season, so 2024-25 season of cover crops, due to a new partnership with University of Minnesota Extension and Minnesota Department of Ag, led by Bailey Tangen and Kevin Keener, who were really enthusiastic about getting growers from Minnesota involved in this project. So really grateful to them for their efforts on that. In terms of the types of cover crops, we've primarily gotten data for multi-species mixtures and for cereal rye, both at about 200 fields in the data set so far. But there are also some winter wheat, clover, triticale, ryegrass, and vetch fields. We're really interested in getting better representation of different cover crop types beyond mixtures and cereal rye, but those are by far the most popular cover crops amongst farmers in the upper Midwest. So it makes sense that those predominate in the data set. A lot of the farms so far have been row crop farms, but we're working on getting more diversified farms involved, including vegetable growers. So if any of you are interested in participating, we'd love to include your farm. There's a pretty diverse range of soil textures represented in the data set so far, as well as topographies. So that's really great for being able to look at sort of if and how cover crop performance varies across these different environmental conditions. We also want to understand how management impacts cover crop performance. So we ask a lot of questions in the management survey, not only about how the cover crop was managed that season, but also about their management approach more broadly. So things like overall tillage practices, crop rotation diversity, nutrient management, etc. And in our data set, the majority of farmers have reported having somewhere between 8 to 12 months of living soil cover on average, which makes sense because they're all using overwintering cover crops, at least on a somewhat regular basis. In terms of tillage, 11% were using conventional tillage on a regular basis. About a quarter were fully no-till, and then the remaining two-thirds, so the majority, are using a combination of tillage practices. So conventional, reduced, no-till practices, depending on, the year, the rotation, etc. We also asked about how frequently participants use organic amendments, so compost and manure. And then based on what they report, we create an organic amendment score on a scale of 0 to 1, with 0 being never using compost or manure, and 1 is very frequent use, like multiple times a year. And the average score across all of the fields so far is 0.16. So that's telling us that most folks participating are not relying super heavily on organic amendments like compost and manure as a major source of nutrients or and organic matter, which does actually end up being very important, as you'll see when I go through some of the results that we're seeing so far. And then finally, for this past season, so 2024-25, we added a few new survey questions based on farmer feedback, including asking about drone seeding cover crops, which is becoming increasingly popular. In the past, we had just asked about aerial seeding, which could include both plane and drone seeding. And so this year we are distinguishing between those two types of aerial seeding, and we are finding that a few folks in the data set are using a drone to seed their cover crops. But the vast majority are either drilling or broadcast seeding their cover crops. A few more interesting management variables here. So as I mentioned, we do update our management questions based on farmer feedback. So we also added a question about whether people were grazing or cutting the cover crops for forage. And we did find that 14% of participants that past season were using their covers for that. We also asked about the soil conditions, specifically when they planted the cover crops, because we'd been getting a lot of feedback from folks that they were struggling with establishment due to dry weather during that cover crop planting window. And it does turn out that over two-thirds of the fields from this past season were what farmers considered abnormally dry at that planting window. So we're really interested to see sort of how this factors into cover crop performance across the region, and if there are any strategies or sort of variables that seem to be mitigating that stressor for cover crop establishment. And then in the bottom left of this slide, you'll see that most farmers are not applying any nutrients to their cover crops. But for those who do, manure is definitely the most common, followed by phosphorus and then nitrogen fertilizer. And then another new question I thought I'd note that we added this past season was about the timing of cover crop planting. So asking about whether it was before, during, or after the harvest of their cash crop. So most folks are planting the cover crop after cash crop harvest, but we are seeing about a fifth of farmers now planting the cover crop either before or during cash crop harvest, so essentially interseeding. And we're planning to look at whether that slightly longer window of fall growth does make a significant difference in cover crop performance. And then similarly, we started asking about whether participants were planning to plant green, so basically planting their next cash crop into the living cover crop in the spring, so waiting to terminate the cover crop until the cash crop has been planted. And we were surprised by how many people said either yes or maybe to planting green at nearly 70%. So definitely seeing this practice becoming more popular in this upper Midwest region as a way to sort of extend that cover crop growing season. And then finally, when we asked about how folks were planning to terminate the cover crop, most were using herbicides, followed by tillage. But we are seeing some folks roller crimping, which is exciting, as well as mowing or cutting. And there were really only a couple of folks tarping the cover crops, which perhaps might be a little bit more relevant to this group. So yeah, definitely seeing a wide range of management practices in the data set. So now we'll get into how the cover crops actually performed across all of these fields. So this table is showing average weed pressure, ground cover, biomass, and nitrogen for the 3 study years. And I guess I can't remember if I've noted this already. We didn't collect data in spring of 2024. I was finishing my dissertation and took a break that season, but that's why you're seeing just 3 years, even though we've been running the study since 2022. Um, So for reference, the weed pressure score is on a scale of 1 to 5, with 1 being really low weed pressure. 5 is really high weed pressure in within the cover crop. And in general, most cover crops are providing pretty good weed control across farms in all 3 years of the project. But for ground cover, which is just shown as a percentage of green ground cover on a scale from 0 to 100%, we are definitely seeing room for improvement to make sure that soils are adequately covered and protected from erosion. And then for biomass and nitrogen, in all 3 years, we've seen that both are extremely variable. So we've had fields with virtually no biomass in every year, as well as fields with several thousand pounds per acre of biomass. In general, research suggests that we should be aiming for sort of a minimum of about 1,000 pounds per acre to start to see some of those nutrient scavenging benefits and reduced nutrient losses. And then for soil health benefits to kick in, there's recent research showing that we should actually double that number to about 2,000 pounds per acre, and maybe even shoot for 3,000 pounds per acre for fields with really stubborn weed problems. So we're seeing that some of these fields are reaching those biomass targets, but there's also a lot of room for improvement, I think. We really want to make this project useful to farmers and other stakeholders. So the QR code that you're seeing in the corner of this slide, if you open that up, it will take you to an online interactive map where you can explore the entire data set. So you can click on different fields that have participated. It'll show you the management practices for that field, the type of cover crop, and all of the performance outcomes that I have summarized on this slide here. You can also filter to see like only certain farm types, cover crop types, or soil types so that you can find the data points that are most relevant to your farm. So definitely encourage you to play around with that. Shout out to Dave Evans for putting that together for us. And then beyond making the data available to explore online through that map, we're also working really hard to actually analyze this big data set to provide more concrete management recommendations. So we just updated our analyses based on the new data from last spring, specifically for cereal rye and mixtures so far, because again, those are the fields that are best represented in the data set. So to analyze this really big, messy data set, we basically feed all of the variables that you see on the left here that could impact cover crop performance, like farmer experience, the environmental conditions, and cover crop management practices into a model that is then able to sort of parse out which of those variables are most important and actually having an impact on cover crop outcomes. So on the right, the variables that were significant for cereal rye are listed in order of most to least important. So growing degree days continues to be the most important factor constraining performance. We've been seeing this year after year. Most farms are really not letting their rye grow long enough, and would benefit from finding ways to really extend that rye growing season to reap the full benefits of the cover crop. And then the second most important factor was actually planting method. We've consistently found that aerial seeding does not seem to do as well as other planting methods, except in cases where the field has a relatively long history of soil health practices like cover cropping and organic amendment applications, which then contribute to sort of better soil moisture and structure that helps aid that cover crop establishment when farmers are using aerial seeding methods. We also saw that soil texture played a role, with silt loam soils showing the best cereal rye performance, and sandy loam soils had lower performance than the other soil types. Sort of unsurprisingly, we did find that the fields in which farmers had applied nitrogen or phosphorus fertilizer to the cover crop did tend to have higher biomass on average than those that hadn't received fertilizer. But that's relatively low on the list of factors here and in terms of significance as well. We did see that precipitation helped boost biomass as we would expect. And fields that had a longer history of organic amendment applications, like manure and compost, also showed a slight performance advantage, likely because of improvements to soil health, as I noted before, from using these, soil health building and regenerative practices that increase organic matter in the soil. And then finally, we did see a small but positive impact of seeding rate on cereal rye performance, which is something that we've been asked about a lot. I will say overall, it's the least important factor. So while it could potentially boost performance in some fields, I think it's really important to consider your specific context and whether or not the additional seed cost is actually worth it for your farm. And then this slide, very similar, is showing the same type of analysis for cover crop mixtures. Um, so we found that rather than growing degree days, precipitation was actually the key factor limiting performance for the mixtures. So this does make a lot of sense because most mixtures are planted after small grains or other crops that allow for a much longer growing window for mixtures than cereal rye usually gets. But because precipitation patterns are so variable these days, a lot of mixtures are underperforming because they don't receive enough rain. Um, what we did find that's interesting and really promising, though, is that the number of species in the mixture seems to provide sort of an insurance effect. So, having a diverse mix of species increased the chances that at least a few would do well under a given set of growing conditions. So, sort of helping buffer against this, these variable climatic conditions. There were some minor differences across soil textures, with mixtures in clay loam soils showing slightly worse performance than other soil textures, but in general, this effect was minor. And then in terms of planting method, drilling was the most effective for mixtures, likely because it's a lot easier to get these different species with different seed sizes planted at the right depth with a drill, or like an earthway, than it is with broadcast or aerial seeding. And then finally, we did find that a manure application immediately before or during the cover crop growing season did have a small positive impact on mixture performance. So I know that was a lot to throw at you, but just some key takeaways here from what we're finding so far, um, is that even though environmental factors do seem to matter a lot and are to some degree out of our control, right? Like temperature, precipitation, soil texture, the management practices that you use can have a significant impact on cover crop success, like adjusting the planting and termination dates of the cover crop, the planting method to be, better suited to your soils and the type of cover crop you're planting, species diversity in mixtures, and even finding ways to combine multiple regenerative practices, like using organic amendments, which kept coming up as this really important practice to pair with using cover crops to create some positive feedback loops between the two practices. We are also seeing that context really matters. So, in other words, it's really important to take all the factors on your farm into consideration to figure out what might work best for your specific situation and goals. So, we're hoping to dig into more of these sort of context specific questions as the data set grows. For example, even though we found that increasing the rye seeding rate can produce a slight improvement in performance. If you already have really healthy soil that supports excellent rye growth at a lower seeding rate, there might not be a need to spend that extra money on the higher seeding rate. So can we dig into that type of question a little bit more? And then similarly for mixtures, does higher species diversity still confer an advantage if your soils are already really resilient to some of these variable precipitation patterns because you've already been using soil health practices for a long time? Um, I will note we're really excited to have another season of data collection underway right now for the 2025-2026 cover crop season. That's going to allow us to really better understand some of these newer practices farmers are experimenting with, like planting green and interseeding, drone seeding, grazing cover crops, different termination methods, things like that, and really figure out sort of what the impact of those practices are on cover crop performance. And just a quick plug, if you're at all interested in participating, we would love to include your cover crop fields this year. Um, all types of farms and cover crops are welcome, as long as it's an overwintering cover crop that you expect to terminate in spring of 2026. And then in return for participating, we do offer $50 per field for up to 3 fields per farm. And we always provide a personalized cover crop report with your biomass and nutrient estimates, sort of relative to the rest of the field in the project, so you can sort of gauge where you're at with things relative to the region. If you scan the QR code on this slide, it will take you to a quick Google form where you can sign up, or you're welcome to also just shoot me an email if you're interested. So I'm gonna switch gears a little bit. So this next project I'm going to share with all of you does stem directly from the Great Lakes Cover Crops project and the protocols that we developed as part of that project. So up until this point, all of the farmers participating in the Great Lakes Cover Crops project would have to wait until our research team had time to actually process the cover crop field survey data that they submitted before they could receive their biomass and nutrient estimates. And I'm really excited to share that we just received funding to actually automate that whole process with an app, so that all you'd have to do is upload your ground cover photo and your stand heights and the weed rating, which is just a 1 to 5 rating, and it will give you a cover crop performance data in real time. Obviously, this will be really, really great for the future of the Great Lakes Cover Crops Project and other citizen science efforts. But we're also really hoping that it will sort of empower producers, conservation professionals, and other members of the agricultural community to use more data-driven approaches to farm management and conservation. Up until now, there really hasn't been an easy and accessible way for most people to accurately quantify cover crop biomass in their fields. For any of you who have been involved in on-farm research before, or if you like to monitor your own cover crops, this photo here might look a little familiar to you. So this is a quadrat, and in most research studies, the gold standard is measuring biomass using a quadrat, shown here, where you have to clip all of the plant biomass within the quadrat, and then you dry it, weigh it, and that's how you get an estimate of in pounds per acre of the dry plant biomass. The major drawback to this method is it can be pretty time consuming, especially if you want to measure multiple time points or locations. And if you're not someone with access to specialized equipment like quadrats and drying ovens, it often means you have to pay money to send your sample off to a lab for analysis. The other method that is becoming increasingly popular is remote sensing that uses satellite data to detect cover crop biomass, which again is great if you have specialized skills and resources, but it's really not a very accessible option for most people. So there are also limits in terms of spatial scale with remote sensing that might be particularly relevant to this group. So for instance, if you're trying to measure biomass in smaller areas, so not like a multiple acre field, remote sensing may not always have the spatial resolution to actually pick up on those, field or plot boundaries. So our alternative method, just using the photos and the stand heights, is hopefully going to be a really, really useful way to collect free and user-friendly biomass data. We've been collecting lots of ground truth data over the past several years from a combination of real farms and experimental plots to calibrate our percent cover and height method. And so far, we do have really high confidence that it works great for various grasses like cereal rye, winter wheat, annual ryegrass, triticale. And so that's the what you're seeing in the upper left of the slide here, really strong relationship between percent cover and height protocol and actual biomass, which is shown on the vertical axis. We're also seeing pretty good evidence that it works well for multi-species mixtures in the upper right corner. Clovers are down in the bottom left. And then it's even seeming to work pretty well for climbing species like peas, which is shown in the bottom right. And we're working on gathering some additional data to really flesh out these relationships over the coming year. So here you can see all of the different locations where we've tested this method with the points color coded based on cover crop species or type. We're still working on polishing up this map, but it will be publicly available as part of the app for anyone interested in sort of seeing where the data are coming from that are informing the algorithms and calculations behind the app. I will note we do love partnering with people to gather more ground truth data to validate the models for more locations and cover crop species. So if you're interested in helping with that, definitely reach out and we can chat about that. And then in terms of potential use cases for this app, there are a number of ways that monitoring cover crop biomass can be really helpful. For example, simply knowing which types of cover crops seem to do better in your fields is useful information for sort of future planning and decision making. And you can also use the data to sort of track progress over time or think about how differences across years or across fields, management practices impact how your cover crops perform. We've had quite a bit of interest in using it as an easy way for cover crop incentive programs to offer a bonus payment to farmers who reach certain biomass targets. And of course, it also opens up a lot of doors in terms of community or farmer-led research and experimentation. We are also working on compiling data to integrate some additional features into the app that we're hoping will be useful, like an environmental benefits summary of sort of whether the cover crop has reached those key thresholds that I mentioned. So for retaining nutrients, building soil health, suppressing weeds, so like 1,000, 2,000, and 3,000 pounds per acre. We're also hoping to include some nutrient estimates, like the carbon to nitrogen ratio and total NPK contained within the cover crop. We're working on a 7-day biomass forecast that would predict how much additional growth might happen. For example, if you let the cover crop grow an extra week based on your local weather forecast. And then also, hopefully, down the road, there will be an option to create an account in the app so that you can actually save and track your progress over time across different fields. Initially, at least, it'll just be sort of a web app that you can open up and you don't have to create an account. It'll be, free open access to everyone. And yeah, we'll go from there, adding different features and functionalities. If you would like to be involved in some user testing for this app later this year, probably in the fall, definitely reach out so that we can incorporate your feedback. We'd love to have people test this out and let us know what they think. And then the last project I'm going to share with you all is the cover crop variety testing network. So this one is relatively new. This just started up about a year and a half ago. And so we're trying to get the word out about it so people can use the data coming out of this project and potentially even participate themselves. So we started this network in recognition of the fact that a lot of cover crop research and trials have really just been focused at the species level. But there's actually a lot of cover crop diversity within each species at the variety level as well. And we really don't yet have sort of a large scale coordinated effort to test which species and varieties are, showing the best regional adaptation, will work for different management goals, different management practices, etc. And just to sort of drive this point home, just like there are sort of different varieties of tomatoes or corn or soybean, there are also different varieties of some of the most popular cover crop species, some of which may work better than others for your farm, depending on your climate, your soil type, management practices, crop rotation. And so the picture here is showing that. For Balanza clover, the variety on the left was specifically bred for use as a high biomass, high nitrogen annual cover crop, whereas the variety on the right is actually an older variety with dramatically different characteristics in terms of growth, maturity, and other traits that might make it a less suitable option as a cover crop. So our goal is really to help farmers find the right cover crop variety for their specific needs. We launched the network in fall of 2024 in partnership with the 12 research sites here, spanning a pretty wide range of soil and climatic conditions. And then this past fall, so fall 2025, we actually expanded the network to include 50 on-farm sites, shown in blue, in partnership with producers all across the country. So we have all types of farms participating, ranging from small-scale diversified vegetable farms all the way to large row crop farms. The trials currently include 20 no, 35. I think it's 35 different cover crop varieties now as of this season, representing 7 different species, including winter pea, crimson clover, balanza clover, hairy vetch, cereal rye, winter canola, and radishes. The varieties are a combination of commercially available varieties, so ones that you could go out and actually purchase yourself right now, as well as some experimental varieties from our sister network. It's called the Cover Crop Breeding Network. And that's a public plant breeding program based out of Cornell University, where they're working to develop new and improved cover crop varieties that meet the needs of all the different types of farms that we have across the country. So the varieties that you see here that are marked with a little asterisk, and a lot of them have sort of like a funky letter and number code rather than a catchy variety name. Those are the experimental varieties that the Cover Crop Breeding Network is developing. In terms of data collection, the metrics do vary a little bit between the research trial sites and the on-farm sites. But in general, we're looking at things like fall vigor, so how quickly do the plants establish and grow in the fall, winter hardiness, uniformity, weed suppression, the maturity, how easy they are to terminate with different methods, fall and spring biomass, stand height, as well as the amount of ground cover that they provide. And to account for all of the variation that we have across the on-farm trials, these farmers they're managing the cover crop variety trial in whatever way they normally would manage their cover crop to capture all of these different types of farming systems. So we have all of these participants enter information about how they managed the cover crop trial, what the environment was like throughout the season, sort of similar to what we have folks do for the Great Lakes Cover Crops Project. So this information is really helping us sort of interpret the trial results by understanding the specific context and the conditions at each individual farm with a trial. So this includes things like the preceding crop, planting date and method, termination date and method, subsequent crop, and we also want to know things like the type of soil and the quality of soil at the variety trial plots, soil moisture at the time of planting, and any climate stress throughout the season, so we can really understand which varieties are performing best under different conditions. For people who want to invest a little bit more time and energy into data collection in their variety trial plots, we do have some optional metrics that they can collect, including disease observations. They can even dig up roots to look at the size of the root system. They can upload photos and comments about any pollinators or beneficial insects that they see in the plots. And for anyone sort of planning to graze or cut the cover crops for forage, they can evaluate the regrowth potential by performing the quick and easy biomass protocol that I talked about a few slides ago at multiple time points throughout the season. And just a quick note that we're really fortunate to be partnering with an organization called SeedLinked to manage and coordinate these on-farm variety trials. So SeedLinked is essentially a participatory variety trialing platform that was originally created really for vegetables, but we've been making tweaks to it and working closely with their team to adapt it for cover crops. So everybody participating in the trials can upload observations and photos. They can view results and they can even interact with each other using a community discussion feed, all in this one variety trial platform. To see results from the trials, we do post an annual report in late spring, early summer to the University of Missouri Center for Regenerative Ag website. We also host a webinar to give sort of an overview of the findings for that year. Last year, we just had results from those 12 research trial sites, but this year, we're really excited to share preliminary data from the on-farm sites as well. Um, we are planning to expand these trials this coming fall. So if you're interested in getting involved, maybe even planting a trial on your own farm, definitely shoot me an email and I can send you some additional information. And with that, I will throw my email up there if anyone would like to reach out or if you have questions. But yeah, would love to hear people's thoughts about all of those projects. If you have questions, yeah, happy to answer those. Always open to feedback if there are things that we could do differently or improve to make all of this work more useful.
Thank you so much, Etienne. This was fantastic to hear more about your project and so much great data coming out of it. And I'm really hoping more veg farmers can get involved in this work, like especially thinking about like the organic diversified growers I work with, looking at how the organic amendment use affects cover crop performance, since that seems a little more common in this group compared to some of the other groups you're working with.
I see a question in the chat. What does 12,000 pounds per acre of cover crop biomass look like? That's a great question. The field that we had with 12,000 pounds per acre was a farmer in like the very southern part of Indiana. He had a really high diversity mixture, and he sent photos of this mixture, and like it was almost as tall as he was. There were small grains, there were legumes, like the vetch was, almost up to his head. And so it was just a cover crop that he had really, I think he had planted it relatively early, and then let it grow into June. So yeah, it just had a tremendous amount of growth. And he's in a location where he gets, plenty of rainfall. So the cover crop was very happy. Um, but in case it's of interest, I do have, I didn't include it in this presentation, but I do have a slide that shows sort of like what do different amounts of cover crop biomass look like. So happy to share that if that would be useful at all, just as sort of a visual reference. Yeah.
Yeah, Etienne, maybe if you could send that to me and I could share it out with the group afterwards. I think that's always helpful for people to have kind of a visual idea of what they're looking at.
Definitely.
And I've seen levels like that for winter rye when we've planted it a little on the early side, like in mid to late September, and then let it go through till early June. So it'll be about 6 feet, and we're planting at about 180 pounds per acre, so pretty high rate. So it's a fairly dense stand, but we've gotten levels up to that.
I'm curious, what was the maturity on the rye looking like at that point once it gets that big?
That was rye that we were crimping, so it was at anthesis, it was flowering.
Okay, gotcha.
And
I'm
actually, I
curious.
can probably find some pictures as well that I can share.
I'm curious if, and maybe I missed it, but if you're looking at like the timing between maximizing biomass but not really tying up too much of the nitrogen for the following crop, for the most part, the way that we're using winter rye is letting it get about 3 feet tall, 2 to 3 feet tall, and it seems like if we really let it go too much more than that, it's problematic for just like too much material and likely nitrogen. But are you doing actual research with people that are tilling in cover crops and like where it is on the kind of biomass range that is ideal?
Yeah, so lots of questions about that from lots of farmers. So we're currently working on compiling a data set. Some of the data do come from the Great Lakes Cover Crops Project and also integrating data from other researchers that they've collected, looking at, for example, is there a relationship between the height of the cereal rye and the carbon to nitrogen ratio? And so if we can figure out if there is a reliable relationship there, we could begin to provide some useful management recommendations to farmers. For example, you said you aim for about like three feet high, and that might be sort of a key threshold. Like if you stay below this height level, you're going to be making sure that you're not tying up nitrogen after termination. Whereas if you get above this certain height level, your C to N is going to be high enough that there will be some nitrogen tie up after termination. So we're working on that. I don't have any like concrete numbers to give you as of right now, but it's something we're hoping to integrate into that cover crop performance app that I mentioned, to provide some more useful sort of management relevant info.
I have another question with regard to mixing species. I'm pretty shy to do a whole lot of mixing based on, I guess, keeping things simple, but also um, perceived benefits of like if I've got a cover crop that needs to be managed with mowing, and there's all sorts of species in this mix where I see like once they're mowed off that first time aren't responding much, like sunflowers or kind of maybe most of the annual forbs that might be in a cover crop mix. Can you speak to like what I'm maybe missing about like why there's such an emphasis on like all of this mixing when my perception is like we're killing off like a whole bunch of that diversity on the first mowing. Um, is it still worth the effort to be like putting a crop in even if it's gonna get mowed off and then it's likely pretty stunted or maybe not even come back from it?
Yeah, I think in that specific context with the mowing, we haven't really studied that that specifically. I will say we are really hoping to dig into the mixture piece a little bit more because when we first found that these high diversity mixtures were that was like sort of the key to getting a good performing mixture. We were surprised because there's a lot of other research from field trials showing that it's like sort of the functional diversity of mixtures. So like pairing a grass with a legume, and not necessarily like the total number of species. Like you shouldn't have to go and max out the number of species in your field. So we were actually kind of surprised when that result kept coming up from this on-farm data set. So we're trying to parse out sort of like what is it about these high diversity mixtures that's actually conferring better performance? Like, is it that they just seem to work better across lots of different soil types? So like a hedging your bets kind of situation? Or is it like really just fields where they might be facing these really variable precipitation patterns? Is that where the high diversity mixes do best? But in general, I think it's such a like site specific thing. And so if you find a mixture that works really well for you, like there's certainly no need to change it up, right? We're just trying to sort of help farmers figure out like what is it that we're seeing tends to work well when it comes to mixtures to give them a starting point. Um, Rue, I see you left a comment here. You want to chime in?
Oh, I no, I was trying to do it quietly. I just wanted to link a case study for one of the farmers that we work with in central Wisconsin. He has a really interesting management strategy that involves some staggered seeding and sequential mowing in a full year fallow. So not everyone has enough land to do a full year fallow, but um, the case study is pretty long. I'm not going to try and summarize it, but it's an interesting read. So I just linked that in the chat.
I was curious, maybe I think I missed, like when you're talking about the results of measuring the, I guess, like the rating. I don't have the words for what you said. But when you have the mixes and you're getting good results, is it biomass that you're looking at, or is there like a qualitative like function or some other test that you're able to like see the benefits of a mix versus the when you're comparing versus just like a single or two species?
Yeah, so in this study, because it is all sort of like crowdsourcing data, where we're really just relying on biomass as the key performance indicator, we do have sort of like weed control and ground cover as supplemental metrics. And then we also estimate the like total amount of nitrogen contained in the cover crop because it's so strongly correlated with biomass. And so those are the key things that we're basing, the results off of. I would love to do sort of like a multifunctional analysis. It's just a little tricky without having like concrete samples to analyze per se in a lab. So yeah, if folks have other ideas for how we might do that, like integrate other types of metrics, that would be interesting, but it has to be something that farmers can like go out and easily do in their fields. I guess I will mention, we do have some data on sort of like the evenness of mixtures, so how well represented all of the different species are. It's very messy, and I have not been able to like go through and clean it up to do an analysis, but that is one thing that we could look at in the future if that seems useful. Like if it's just one species totally dominating, or is it actually, all the species coming up sort of thing.
We still have time for questions and discussions, so I don't want to interrupt that, but I am going to put the evaluation in the chat to let us know if this was helpful for you and future topics that you'd like to see. So I'd really appreciate it if you could fill that out.
I will go ahead. I'm going to drop in the chat a link to the interactive map that I mentioned. It's just kind of fun to poke around and see what people have planted and, how things turned out and play with that.
I kind of wonder when it comes to like the multi-species cover crop plan, if and then maybe you've found this too, or other farms have noticed that maybe it's a better plan in that case to do stuff like I have a mix that's going to be winter killed as opposed to trying to do any sort of mowing or any other sort of cultivation techniques to it. Do you know anything? Have you found any of that to be true or?
So we're a little bit limited in being able to look at those things because we have so few folks in our data set who have been doing like mowing throughout the season. And so, yeah, certainly if any of you are doing that and would like to join the project, we could start to answer some of those questions with a bigger sample size. But with this specific project, we have not really been able to start to tease apart anything related to that, unfortunately. I don't know. Do other folks have insights or experience with that?
Rufus, are you talking about like no-till planting into winter kill, or just kind of having it be winter killed so that you have an easier time getting in?
Well, I'm kind of wondering about it seems like you have two different cultural practices you're trying to do. Like winter rye, obviously that's going to be overwintered and you're trying to get as much biomass in that just single planting. But like perhaps these mixes, or maybe there's a mix out there that's multi-species mix that could be planted in the summer, that's designed to get it, you get as much growth as you can out of it, of all the species, and then all the species die over the winter, and then your beds are ready for the next season.
Oh, yes. Okay. Definitely, we do have people doing that. It's not really represented in our data set because we're specifically looking at overwintering cover crops. But I have spoken to a
Mm.
lot of farmers who will plant like a 12 species blend of species that come up really nicely, like in August, for example. And you do get like a lot of growth if you're planting the right species. So like not cereal rye, don't plant that in like July.
Right,
So
right.
yeah, there are definitely blends that you could do to fit that window.
So you have folks that have those blends that have been working with them, and you have that information.
Yeah, I could. There are a number of farmers I could reach out to and get sort of like the specific details on all of the species and the seeding rates for that. I think some of them have worked with sort of like local seed salespeople to design the mixtures. But yeah, I'm happy to share that.
I'm curious, why you say maybe to not plant rye in July or August.
Uh, so cereal rye, it's really like a cool season species. And so like it will grow if you plant it earlier in the year when it's hot out. It just won't be very happy. It's really meant for that sort of like planting in the fall, letting it grow into the spring type of window. There are certainly other species similar to cereal rye that would do better. Like if you're looking to really maximize growth from say like midsummer to when frost hits, there are definitely other species that I would look to instead, like sorghum Sudan grass. Yeah, there oats even would probably do a bit better than cereal rye during that window.
I think one thing that we've experienced, Rufus, with like the winter kill situation, where we always thought like that, we've always heard from a lot of people that rye is really wet and hard to get into in the spring. But we had a couple of times where we had a thick winter killed mat of oats, and that never dried out. And then the rye was still growing, so it was able to actually like suck the moisture out. The other thing that
Mm.
we, the other thing that we do realize is when we till in rye in the spring, it almost always seems like it's too wet, but it's not. Like we're tilling in rye under pretty wet conditions, but because there's so much material there, it's like not damaging to the soil like if we were tilling in bare soil, if it was maybe the same amount of moisture. So it's not like we're waiting um, for it to be like totally dry when we when we
Yeah,
till it in.
that's fascinating. Yeah, thanks, Mike. That's really interesting. Yeah, you don't even think about that, like the map that winter kill creates, just holding everything in there. Yeah, that's really interesting.
Yeah, it can hold the cold in, and it's like it can be insulation for all the moisture and everything to have a hard time drying out in the spring.
Have you ever let that winter kill go further into the season? Like had some beds that you didn't necessarily need, like the planting window was a little bit later, and just sort of let it keep decomposting and whatever?
On our farm, we don't do much winter kill because we're almost always trying to maximize the amount of photosynthesis. So even if
Mm,
something's going to be planted real early in the spring, and it's like, even if we can only get like 2 inches of rye growth out of it, it might seem a little bit um, excessive to even plant the rye, but we've seen like changes in like the soil movement in the winter is definitely slowed down, even if there's only like the tiniest amount of roots, like rye that's growing. So we pretty
mm,
much plant rye at all sorts of different stages, um,
mm,
tilled in at different stages for like the different planting windows.
mm. Interesting.
Les McCary from Racing Heart Farm has talked about planting into winter-killed oats as well. It might have been an oats and peas crop that was planted in the fall, winter-killed, and then they went in and planted. I know they planted potatoes into that, but Les talked about that in a previous meeting, and the recording for that should be up on YouTube, so I can share that with you if you're interested, Rufus.
Yeah, that'd be great. Thanks, Ruth. I'm wondering if Tenzin has any, if there's anything in that report that you shared about his experience, if he does any winter kill.
I think it's more that with that multi-species cover crop, um, because it is a mix of winter hardy and winter killed covers that
Mm, okay.
are seeded sequentially. Um, so I think some of his earlier season management is intended to kill off the rye, and I think there might be vetch in that mix as well. And
Mm,
then he's seeding in the summer cover crops, which are then coming through. So I think it's more about his timing of management, so that he can maximize diversity. And also, he's really trying to keep a lot of the material as low carbon as possible, like just not letting it get too big and get too woody.
mm, interesting.
One thing that we have kind of landed on as far as like different species over the same field with like less tillage is if we have a real long window. We've been doing a lot of sorghum Sudan and then mowing that like extremely low. And then on a fairly wet day, going in with a grain drill. And it's not like a no-till drill, but because it's like fairly wet, we're just like seeding rye almost right on top of the soil. It goes in a little bit if it's soft enough. And then we're getting like two grass cover crops on top of each other without having to do tillage. We
Mm,
used to do that more than we do now because we learned that we're actually having pretty good luck just planting clover right with the sorghum. And so as long as we have a good clover stand, we don't do the rye as much anymore. But this year, on some of the fields where the clover wasn't good, we then went through in those spots and planted rye. That's been a pretty good system for reducing tillage a little bit.
mm,
I'm curious.
nice.
Oh, go ahead. I, w
I say I just have like,
I was just gonna ask what type of clover you've been planting.
I think for the most part, we're planting mammoth red clover. I think we've done medium red clover as well, but we're a vegetable farm. We're typically tilling in the next year, so we're trying to get just the quickest growth. Um, and we're not looking to like mow it and have it come back. So we've been doing mammoth, but I think if we were really thinking far enough ahead and we had like a full season of clover the next year, we might consider starting to do some like sweet clover or just like a clover that can handle being mowed. But for the most part, I think we're tilling it in and planting a cover crop or planting a cash crop. But I don't know much about a lot of like some of the clovers you had listed. I don't know anything about, so maybe there's certainly better options than what we're doing.
Yeah, we're still figuring that out. I'm yeah, anxiously awaiting all of the on-farm trial results this year to see what folks are seeing. Yeah, the Balanza clover has been super hit or miss so far. There is one variety that seems pretty promising that's like relatively newly developed. But yeah, stay tuned. Hopefully we'll have some useful data for everyone to see. Especially like for the legumes. One of the things we're really excited about is the overwintering potential for folks in, like Michigan, Wisconsin, Minnesota, to see what seems to do well in those environments.
Yeah, we've done a little bit. So if we're planting like real late in the fall, and that overwintered cover crop is not going to get a whole bunch of growth on it, that's usually not a scenario that we would want to put clover seed down in the fall. I'm curious if it would work. I guess it's not something I've done a lot of trialing with, but I just kind of expect that it would be less successful. And in those situations, we really want clover down. We'll just frost seed it. So we'll have like lines of cover crop that are coming up, but they might only be a couple inches tall in March. And then we've got a lot of like kind of exposed soil for that frost seeding to stick to.
Yeah, I have heard from other folks they've tried that as well, and it seems to work pretty nicely with the clover at least. I think the only legume I've heard that seems to actually, like if you plant it a little bit later in the fall, is hairy vetch, that it'll actually like get up and do well in the spring. Um, but yeah, for the clover and like winter peas, they seem to struggle a little bit more if you wait too long to plant them in the fall.
Anyone else have any questions or comments?
Well, I'm still kind of interested too, and like Mike, maybe you can talk about this more too. Is this the conflict between trying to, especially in the veggie world, so you've got the wanting to achieve as much growth of your winter rye, but then of course like the winter rye affects the next crop going in, and so like where is the in the veggie world, where's the most benefit? We're not necessarily needing to achieve maximum growth. Um, and it seems like maybe just getting it in the ground and having some growth is nice.
Yeah, I think on our farm, we do a lot of transplanting with water wheel transplanters, which allow us to plant into pretty trashy ground. Um,
Hmm.
but in the cases where we do use a carousel, we do like soil management practices that are very much less conservation minded because we need the equipment to work right. Um, and that
Right.
and that has turned into some like fall tillage for us. And one thing that we've actually done this year was planted winter rye in August and had like just a thick stand. It was quite happy. It was not tall. I'm kind of curious what the biomass was in it because there was so much there. And I realized I need to plant onions into that. Use a carousel planter in April. I need that ground to be like um, pretty clean. And so I rotivated that rye down in the fall. And it'll still be a bit, I mean, I didn't feel that bad about tilling right before winter. I don't know if that's allowed to say on this particular group, but like the ground out there is like, there is still like huge amounts of cover crop there. The rye is not even dead. Like it's very wanting to be
Mm.
alive. So it's going to regrow. But I started that tillage process in the fall in order to have a chance at getting like something that's going to work for my equipment. Um, so that's one aspect of it. And then there's a lot of people that talk about rye and affecting like allelopathy or nitrogen. And my experience is that that is not something that I think about too much anymore. We plant rye in front of almost every single thing we grow, and we till it in at like so many different stages. If the rye is like 3 inches, 4 inches tall, and we till it in and direct seed into it, I've never like had something that I would associate like germination problems because of the allelia pattern.
Mm.
We do typically till whatever size rye there is. We try to till like I mean, I think 3 weeks would be generous, but we're probably more like 2 weeks. 2 weeks ahead, like tilling down 3 foot tall rye. We're not tilling it very deep. We have like a pretty heavy duty rotavator that will till like maybe 2, 3 inches deep. We're putting just like a ton of residue all right there, and then let it sit for 2 weeks and then come back, till and plant. It's pretty much our strategy. And our soil seems to eat up all that material.
You're a little more sandy too, though, aren't you, Mike?
We have 3 different locations. One of them has a little sand on like the shoulders, but for the most part, it's pretty more heavier. So
Okay.
Well, thanks so much, everybody. Etienne, thanks so much for being here today. Thanks for the great discussion. And please join us next month, February 11th. We will hear from Sandy of Whitewater Garden Farm. They just wrapped up their SARE project on no-till methods for veg farms. So be excited to hear.
thanks.
Thanks so much.
Thanks, Etienne. Thanks, everyone.